In this video, we will use the Taylor-Maclaurin series sum expansion to generate a trend line of the Weibull in probability density function and cumulative distribution function. Our values of beta will be from 1 to 3. So data validation, list of items, 1 to 3. You can start with 1. Likewise beta. So data validation, list of items, from 1 to 3. We can also start from 1. And k will be 0 or 1. So data validation, list of items, 0, 1. And we can start with 0. Next, the dataset of the Weibull function in probability density function. Array formula, Weibull of the x values and our alpha, our beta, and 0 because this is cumulative, just the probability density function, and the cumulative distribution function. So array formula, Weibull of the x values, our alpha will be this value, then our beta, and 1 because this is cumulative distribution function. Now we continue with the Taylor-Maclaurin series sum expansion for both, which is the summation of a times x to the power and a alpha minus 1 plus k plus alpha n, where the value of n is from 0 to infinity. And the value of a, the expansion coefficient, is array formula, minus 1 raised to the power n divided by, that's the numerator. The denominator has 3 parts. Beta raised to the power alpha plus alpha n. So beta raised to the power the quantity alpha plus alpha n. Alpha times n. So that's the first part. The second part. The second part is factorial of n plus k. So factorial of n plus k. Finally, the third part. The third part is alpha raised to the power the quantity k plus 1, k minus 1. So alpha raised to the power the quantity k minus 1. So k minus 1. And then, now we can complete the Taylor series expansion, which is equal to array formula, series sum of the x values raised to the power alpha minus 1 plus k plus alpha n. So it starts with alpha minus 1 plus k. So alpha minus 1 plus k. That's the starting point. Incremented by alpha n. So comma. Alpha n is alpha times n, where n is from 0, 1, 2, 3 up to infinity, and the interval is 1. So therefore, the interval will be alpha times n, which is alpha. And the coefficient. The coefficient will be this range. And we'll chart this. Insert chart. And we use scatter chart. Column A as label. We don't need the title, so we delete this. Now for the series, show the trend line. The type, polynomial. The degree, 6. For the label, use the equation. For the legend, position at the bottom. Now for the series, point size will be maximum. Except for the expansion, the point size will be none, but its line thickness will be maximum. So here's the trend line and polynomial of the Weibull function in probability density function and cumulative distribution function. We calculate this polynomial regression coefficient using LINEST. To do that, we complete the LINEST matrix, starting with the power. Transpose 0 to 6. And the elements of the matrix are a formula of the x values raised to the power 0 to 6. Now we can calculate LINEST, starting with the probability density function. LINEST data y and data x. Also LINEST data y and data x. Also LINEST data y and data x. Now we compare the coefficients. So starting with x to the 0, that's 1, 1, 0. This is 0, 9.98 times 10 to the minus 30. Coefficient of x, negative 0.99, positive 0.99. Coefficient of x squared, 0.497, negative 0.497. Coefficient of x cubed, negative 0.16, positive 0.16. Coefficient of x to the fourth, that is 0.0356, negative 0.356. Coefficient of x to the fifth, negative 4.99 times 10 to the minus 3, positive 4.99 times 10 to the minus 3. Coefficient of x to the sixth, 3.3 times 10 to the minus 4, minus 3.3 times 10 to the minus 4. We can toggle this to 1. We increase the beta to 1.5, and we can toggle this to 0. We increase beta to 2. We can toggle this to 1, and then 2.5, toggle this to 0. So what you're looking at are the exponents. Suppose we increase this to 1.5. You can toggle this to 1. Start with 1 and toggle this to 1. Beta equals 1.5. You can toggle this to 0. Beta equals 2. Toggle this to 1. And increase this to 2.5. You can start with 1. It doesn't work, but we can go with 2. Starting 0, 2.5, and this will be 1. This completes the use of the Taylor series expansion in SERIESSUM, LINEST polynomial regression, to generate the trend line and trend line of the Weibull function, both in the probability density function and the cumulative distribution function.